Right, so for the clay experiment, here's my ball of clay. It's pretty big. I'm going to put it in this plastic box. So first I'm going to like knead it a little bit to make sure that the mass is spread out evenly. And roll it around, roll it a little bit. And then I'm going to put it in here. And then I'm going to use a plank over here to flatten it, to create a flat surface. Right, like this. So now I'm going to use this as to drop the weight onto it to measure the impact. 21 centimeters for the one height. Trial 1. Now I'm going to fill up this hole with some water with this syringe. So right now it's completely filled with water. You can see the reflection of my flashlight. Try to fill it up completely. As you can see, it's pretty much in line with the surface. There's just enough water, I think, to be in line with the surface. So now I'm going to suck it out and then measure how much that is, how many milliliters. Okay, it's pretty difficult to see. You can see the line. It seems to be 1.1. Now there are 5 marks per milliliter, so 1 mark is 0.20 milliliters. So it looks like it's 1.20 milliliters. Hold on. I think this one is give you a better view. It's not evenly. It's not really perfectly leveled. Oh, now it's perfectly leveled. Oh, it's almost 1.40. Almost 1.40 milliliters. Yep. 21 centimeters, trial 2. I noticed that in the first trial the plastic box bounced a little after impact. So now I'm gonna hold it with my hands. And then so here it is again, filled up with water. It's pretty much the same as the first trial. See? Okay. Okay. So as you can see, it's empty. And what do we have? 1.40 millimeters. It's 1.40. Now it's 84 centimeters, so 4 times the height, twice the velocity. So once again, the hole is filled up with water, completely filled. So it looks like a crater. So with a crater, you always have at the ends, it sticks out a little bit. So as you can see, the water level is a little bit below the outer ends of the crater. So yeah. Is that it? Yeah. It's above 5. I think almost 5.40. You know, like 2 marks above the 5. I think it's around 5.40 milliliters. 5.40. Yep. 84 centimeters, 4 times the height. Trial 2. Okay. Hold on. Well, unfortunately, I have to hold it at the front, and then okay. So the hole for the 2 velocity is filled up with water again. Empty, and looks like it's not completely full. You can see the line, well, on this side it's not completely full. So 1.4, so for the 1 velocity we had a 1.40 milliliters, so times 4 would be 5.60 milliliters. And now this one's almost completely filled up entirely. There's a little gap over there, so I don't know. I don't know what the maximum capacity is. I think it's just below 6 milliliters, like 5.8. As you can see, it. All right. I think it's 5.60, yeah, 5.80, something like that. Right. So what does this mean for this experiment? Well, it means that when the probe is being released 4 times as high, then we have 4 times as much volume in the hole. Not twice as much, 4 times as much. So quadratically. Which means that yes, kinetic energy seems to be real. So now, this is with clay, and in my previous experiment with the Oasis floral foam, I had pretty much the same results, that that the 2 velocity, the 4 times higher, that it produced 4 times as much volume. So now we have 2 substances that I have used for kinetic energy experiments, and it proved that twice the velocity creates 4 times the volume, 4 times the displacement. Yep, kinetic energy is real, people.